Okay, good morning, everyone. Today is day 2 of week 3, project week. I want to show you guys something interesting. So remember, at this point, I'm coming up with some of the algo material from my studying, and I thought this would be an interesting lesson. So we're going to learn about this inbuilt JavaScript method called .sort, okay? So let's look at this one here. We have an array called var array1, and it has 1, 34, 21, and what number is that? 100,000. Okay, so if I uncomment this, what do we expect the output to be? Any guesses?
1, 4, 21, 30, 100,000.
Okay, let's check it out. Let me clear this here. We get 1, 100,000, 21, 30, and 4. It's pretty interesting, right? Doesn't
So
seem like that's the way it should work.
Is it
So,
sorting by the highest first digit?
yeah, apparently so. So if we use sort on, let's create an array of strings, var string array, and we say apple, orange, banana, BANNANA. Yep, that's how I spell it. Okay, and I say console.log array string array.sort. Let's see what we get. We get a good alphabetical order sort. Okay, but when we're trying to sort numbers, now it's applying this alphabetical order rule to numbers, and it's sorting by order of the first digit, like it would be sorting through an alphabetical order. Okay, so I'm going to show you guys something else as well here. Let's apply let's add in a negative number here. Okay, we'll add a negative number and we'll say array2.sort. Let me just make sure I commented that. Yep. So I want to test this now. Okay, it does add the negative to the beginning when we sort it, but then it goes 1, 1,000, 21, 30, and then 4. Okay, so this is closer to what we want. This is not actually still sorting it the way we would expect it to sort numbers. Okay. Now, here's how we can sort numbers. We have to apply this sort of thing to it. And part 2 of today's algo problem is to research this and to give a good explanation of it. Okay, I'm just going to show you that it works. I want you to look into, in your breakout groups, why this works and to give a good explanation. Okay, so you're going to have to do some Google research, but here's now how we can make this sort. Where you say array3.sort, this is our array, same thing as array2, but now we're saying array3.sort, and then we say parentheses a comma b, and this thing here equals greater than is actually a way to say function. It's called an arrow function. Okay, this is called an arrow function in JavaScript. And then we say a minus b. So if we say array3.sort, and we run this, then we get here the order that we prefer. -5, 1, 4, 21, 30, 100,000. So step 1 is, step 2 is to research why this works. Okay, A comma B, arrow function A minus B. Looks a bit encrypted, but this is going to be the tool that I'll ask you guys to use in today's algorithm. Okay, so first do this algo problem that I'm going to explain to you. Then second, research how to explain why this works. Okay, if you have time left over from solving the algo, explain why this works. For now, just know that it works and that you're going to need to use it for this morning's algorithm. Okay, so now let's jump into the algo problem. Here it is. Write a function that takes in a non-empty array of distinct integers. So this is important. They're distinct integers. And an integer representing a target sum. So it's similar to yesterday's. The function should find all the triplets. This time we're looking for triplets in the array that sum up to the target sum, and return a two-dimensional array of all these triplets. So a two-dimensional array would be like this, an array of arrays. Now we're going to return a two-dimensional array of all these triplets. The numbers in each triplet should be ordered in ascending order, and the triplets themselves should be ordered in ascending order with respect to the numbers they hold. If no three numbers sum up to the target sum, the function should return no three numbers sum up to the target sum. Now, this may be one of the harder algorithms that we've thrown at you guys. I want to see how you guys handle this. You guys did pretty well with yesterday's. I'm testing you to see how well you do with this in your breakout groups, okay? You have the first tool. This is all you need to, this is the only thing that we haven't introduced as well as a tool to sort something, sort an array. Everything else, you guys, I believe, should have the skill level to deal with this algorithm, okay? So let's try to get as much time as we can today, and I will distribute you guys into groups. I'll post this in the Discord chat, and I'll say, you know, part 1 here, part 2, research and explain this once we finish. If you finish this algo problem, okay? Does anyone have any questions? Okay, great. Let's go ahead and get started. I'll post this in the Discord, and I will distribute you guys in the groups. Okay, just hold on while you're in your breakout rooms. I'll post it in just a minute here. So let me distribute you guys first. Breakout rooms. see who's left. Okay. Evan, you're still here? Okay, where do I want to stick you? Stick you in room 3. Okay, everyone, let's get back into this algo. Let's have a group that has a solution present, and if any other group has a different solution, then we'll go through that solution, and then I'll show my solution, and then we'll go through the sort function and its meaning. Okay, so let's get started. Would any group like to share? TikTok. Come on, somebody. I'm gonna start calling on people. You don't have to T-diagram, okay? Not gonna be that hard.
I could share if we don't have to T-diagram.
Okay, thank you, Bill.
Share screen. Okay. So this is what the function that that we wrote. It takes an array and a sum, and then it sorts the array. And then it creates an array to return. Then it loops through the array, or it starts looping through the array. It creates a temporary variable to hold the the sum minus the value of the first element in the array, or each element as it goes through.
Could I interrupt you, Bill, for 1 second? Oh,
yeah.
so on the for loop, you said array.length -2. Why did you say that?
Because it's only going to need to go to the last two elements, or it's only going to need to go that far because the other two are going to be the last values.
Okay, okay.
Because we're not going to repeat the same value 3 times, unless you, sorry about the background noise, unless you want the third value like to be the final value to be like, or the same value to be 3 times in the array.
Okay.
So if the final values are accounted for, sorry about the background noise. If the final values are accounted for, it with the other variables, then the first index doesn't need to go all the way through to the end. At least that's what I figured anyway.
Okay, let me try and draw this out so I can understand here. So you have, let's say you have an array and it's -8, 2, 4, 5. So I is only going to this position, right? That's where, oh no, it's going to end at the second to last. So it's going to be here.
Right.
I is going to end its search there. And then we'll say K, or no, J is I, we say array.length -1. So J is going to be here. Oops, I erased everything. Okay. Well, let me try it again.
And J will only go to the second last.
Second to last, and then K will go to the
last.
The very end of the array.
Yeah.
And you said J equals I plus 1, so you're saying move up a space in the array from I.
Yeah, because J will never be the first value for the same logic.
Okay, and we also said K is going to be up 1 from J.
Yeah.
And if K, if array at K plus array at J is equal to temp, then, and temp is going to be the sum minus R at I. If it's equal to temp, then push I, J, and K. And does this work?
Yeah, it ran down here at the bottom.
Okay. Okay, cool. So this is a triple nested for loop. So we would have to do a lot of operations in order to solve if this works. Okay. So because we would be T-diagramming for a while here, let's just take a mental image, or this will be on the recording as well, so you can always go back to the recording and look at this code to see how this works and T-diagram it yourself. Okay, I would encourage you guys to do that when you have some spare time. And why did we have to sort the array at line 20?
Because you told us to.
Literally.
All right, okay, fair enough. But why did I tell you to do that?
So that we could return the values in ascending order.
Right, okay. Yep, that is part of the algo. So does it help at all with finding the sum? What does Joe say here? Joe says because if the array is not sorted, the logic is going to fail. Right? Why would Joe say that? Why would the logic fail doing a triple for loop? Okay,
By default,
sorry.
maybe because maybe by default string is sort it's like in ascending order.
Right. Oh,
I mean string. I mean numbers get considered like string, and it's sorted in ascending order.
yes, yeah, okay. But I guess, yeah, that would be the best answer for now. So let's go ahead and share my solution, and we'll try to T-diagram mine if I don't mess up with the Zoom annotations here. So let me try and move that here. So this solution works without a nested for loop. Okay, so let's take a look at it. And here it is. So let me uncomment it. All right, so here we have a function, and it's called 3-number sum. It takes in the array. So our array is this one here, and it takes in that target sum. Then we sort the array, and I'll explain a little bit more into that why we have to sort the array. But we have to sort the array to make this logic work. Then we make this array called triplets. This is what we're going to be pushing into. This is the grand result that we're looking for. This here, an array of arrays. So we'll be pushing arrays to this triplets array, and that's what we'll be returning at the very end. Okay, and then we start with a for loop, and we say, let I equal 0, and while I is less than array length minus 2, I plus plus. Okay, so let me try and draw this out on the side of the screen. So we have our sorted array. So we'll just say 1, 2, 3, 4, 5, 6, 7. Okay, this is just an example array. And we have here I being at 0, index 0. And then we say, well, I is less than array.length minus 2. So array.length minus 2 is going to be the second to last position. This one here, the 6, right? So I is going to go all the way to 6, this position here. Okay. And then we have a variable called left. And we say left equals I plus 1. Okay, so left is going to be, let me make left a different color. I'm going to just make it an L here. I plus 1. L for left. And then we say right equals array dot length minus 1. Okay, so right is array dot length minus 1. So that's going to be all the way at the very end. So we'll say R. Let's make R a different color. Here we are. R. Okay, so we have 3 markers on our array. We have I, we have left, and then we have right. And so now we say while left is less than right, because we're going to be increasing I in this for loop as we increase I in this for loop, right? We're going to increase here, and that is going to push left over 1 spot. As we increase I and I goes from 0 to 1, left is going to move over 1 spot too. And so then we say, while left is less than right, const, remember this is just another name for variable, current sum, we're going to make this new variable called current sum, and we're going to say it's going to equal to array at I plus array at left plus array at right. So we're adding I, left, and right. And then that current sum is going to help us determine whether we need to move our left array or our right, our left pointer or our right pointer in the array. Okay. If it so happens to be that the current sum, the left plus I plus left plus right, is equal to the target sum, then we push this these triplets to the this array, this empty array. So we say array at I, array at left, and array at right. Push this array of these indexes, their values. And so if and then we increase the left by 1. So the left would move over 1 spot. It would move over to here. And then the right would go over to the left 1. Right? Right minus minus. So that would go then to 6. And then we continue to check in this while loop. We're still checking this while loop here. Is left still less than right? Yes. Okay, then we redefine the current sum. We say it's at I plus array at left plus array at right. So we redefine it, and if that current sum is equal to the target sum in this instance as well, then we then add that to the triplets array. So we're checking every possible combination and adding that to the triplets array. So we're checking when I is at 0, and then left is I plus 1, and then right is all the way at the end of the right. And if for some reason it is not equal to the target sum, then we're increasing left. If current sum is less than the target sum, then we're increasing left. Otherwise, else if current sum is greater than target sum, we're decreasing the right. And so that's why it's important that we sort this array, because the sorted array allows us to decrease right or increase left to check every possible combination in that ascending order.
And being if your current sum is too high, you want a smaller number, so you increase left. And if
Yes.
it's too big, you subtract from the right because you're going down in value.
Exactly. We want if it's too small, if our current sum is less than the target sum, then we want to increase left to get a bigger number to see if we can get closer to that match. Okay. Then at the point where we are increasing left or decreasing right, at that point, if left is at the same point as right, if they somehow match at the same position after we've checked all those combinations, then if this is no longer true, then we exit this while loop. And then we increase I by 1. And then I then goes to this position here. 1. I wrote it in orange. Ugh. Erase. Oh, erase the array. This is hard with Zoom annotation. I'm gonna have to use something else here. I'm gonna have to use my own Blackboard to explain this in detail. So let's just go on with the explanation without it, and I may have to use a Blackboard in a second here. So then we increase I. That moves the left position to be I plus 1. So then I would be at position 2. Left would be at position 2 in the array, and right is still at the end of the end of the array, the same position. Then we go through the process again. Is the current sum of the new I, the new left, and the right, is it equal to the target sum? Okay, if so, then push this combination. And then increase left and then decrease right. So we're going to do this at the same time if we meet that combination.
So is the reason why I works to continue going through the loop ascending because you've like at I position 0, you've already checked every combination of other values in a summed with I at position 0. So you essentially don't need that first index value anymore. So that's why you can keep moving through the array.
Exactly. We've
So
already checked I at all those possible combinations with every other index in the array.
Cool.
Exactly. Okay. So I think the best way is to use a Blackboard and do my best to T-diagram this. And then the lesson for today is super short after this algo. So I think it's worth doing here. So let me clear the board. And I'll give an attempt at this. If it's just somehow something breaks, then we'll just move on. Okay. So let me write the function on the left here. So we'll say function 3-number sum and then we say array and we take in the target sum. Okay, then we have to sort it. So we say array dot sort, and we say A, B, A minus B. We'll explain this here if we have some time after, if it's not too much here. Then we say const triplets equals this empty array. This is what we're going to be pushing to. And then we say for, how do we undo? Figure out this undo here. Eraser. This is the problem with this. Anyways, just continue on with the little mark on there. And we say for let I equal 0. And then we say I is less than array.length. Minus 2. That's because we want to leave a little room for the right pointer. We increase I. Okay, then we say var left equals I plus 1. And var right equals array.length minus 1. Okay. I wonder if I'll have space by the end of this. Okay, then we say while left is less than right. Then we say const current sum here. So we say var current sum. Oh, did I already write it right? Wrong. No. While left is less than right, var, I did it. Current sum equals array at I plus array at left plus array at right slowly realizing here I may not have space for T diagram. And then we say if current sum is equal to the target sum, we're going to push to the triplets. We're going to say triplets.push array at I going to push an array into the array at left and array at right. I don't know if I have space. Oh my gosh. Okay. And this is kind of hard to read with the black background. What am I going to do here? I think I just have to go back to this here. And what I'll do is I'll do what Spencer is saying, and I will link this on Discord. You guys can look into this algorithm and test it on your own time. But
I,
what
put it in
this
the-
will do, sorry, Joe.
Oh, sorry, I was gonna say I put it in Discord for you already.
Okay, you did. Okay.
Also, if you're just interested in getting a quick T diagram, we could use that Python tutor thing. I don't know if they're just against that now, but they have that
Python
visualize
tutor?
thing. Yeah, they have that visualize thing on there. It works really good to lay
Oh,
out-
really? Okay. I don't want to experiment with it for the first time, just
Yeah,
in the
yeah,
class.
yeah.
So we'll do maybe another session if you guys are interested with Joe. But what this is doing is it's checking through an array, it's increasing I, and every time I increases, left increases. And so we're checking every possible combination through an ascended array. An ascending order array. And that will help us find every possible combination to add to this triplets array with only one for loop. Okay. And that being said, I think I'm maybe overwhelming with you guys with this type of algo. You guys were able to solve it, but with this explanation here, I may be going overboard. So what we'll do now is we'll just do a quick explanation of how this works, array.sort. So as you can see here, a sort is a function. And in this function, sort, there's another function here determined by this arrow function that takes in two parameters, a and b. And then we say a minus b. So what that is doing is allowing for numbers to be sorted in ascending order. And I wanted you guys to look into why. Okay. So could anyone give me a good explanation as to why this works for numbers?
Yeah, I can.
Okay, great. Let's share your screen then.
Oh, can Evan share his?
Yeah.
I did not have it in my VS Code.
I can do that. Let me just pull up real quick. Just gonna take me a sec, sorry. Okay. What are we looking at? Okay.
Could you uncomment the code that you, oh, there you got it. Okay.
Yeah, I was curious, probably looking for this for explaining. So
Okay, so we're looking at line 8 in this.
let's move this out of the way. My bad. Okay.
Looking at line 8, we're using the sort function. The first thing to know is it seems like the sort function has its own built-in behind the scenes functionality that we have to account for and control for. In the example on line 10 of that second array, the sort function by itself without those parameters in the arrow function would be sorting them by their first letter alphabetically because it's defaulting to sort by strings. But we, rather than wanting to sort by the first letter, we want to sort by the entire value that's held in that indice. So we use that shorthand arrow function in order to get the entire value of an indice and sort it based on ascending order. As you can see on 8, you can substitute those variables A and B for literally anything. It does not matter what it is as long as it's written that way. And what it does is it takes the one position and the value of one position and the position next to it and subtracts the second position from the first position and returns either a true, a false, or a zero or a nothing statement, being that if position 1 minus position 2 is negative, you know that position 1 is smaller than position 2. If it returns 0, it means they're the same. And if it returns positive, it means that the first position is larger than the second position. So all it's doing is comparing two indices next to each other and flipping them if one is bigger than the other or if one is smaller than the other. It does that for each position through the array and runs through the whole array, and then it runs through it again and rechecks those positions to see if it then needs to move values down or up again, until at the end of it, it returns everything as either a positive or a negative result, meaning that the array is sorted either by ascending or descending order.
Okay. So what you're saying then is if it checks value 0 here and then checks value 30, it's going to say 1 minus 30, right? So that would be cat here for 1, and this would be 30, right?
Mm-hmm.
And so 1 minus 30 is going to be negative 29. So then what does it do once it understands it's a negative?
Once it understands it's a negative, if you're trying to assort by ascending order, it leaves those two values alone because it knows that position 0 is less than position 1. Then it will check position 1, 30 against 4. It will subtract 4 from 30, getting 26. You have a positive value as the result, so it knows it needs to flip those around in order to put in order to get a negative value out rather than a positive. It does that for each section or for each two values through the array, and then it goes back through the same array and does it again until all of the returned values or all of the result values from A minus B are negative.
Okay, so it checks this one and this one, and then it figures out which one is greater. If this is already in order, then it goes through this one and this one. This is not in order, 30 and 4, so it gets a negative value, so it flips those around. So then 4 would be where 30 is, 30 would be where 4 is, and then it checks where it would be 4 and, well, and then it would check
30 and 21.
30 and 21, right? Because 30 would be here now. And so 30, that's going to be a positive value. So then it's going to flip it around. So 21 would be where 30 just got placed to, and 30 is going to go to where 21 was. And then it checks 30 and 100,000. And we know that 30 minus 100,000 is going to be a negative value, so it leaves it as is. And then it checks 1,000 and negative 5, and so 1,000 minus 100,000 minus 5, that's going to be a positive value. So then it's going to flip negative 5 and 1,000. So negative 5 is going to go there, and 1,000 is going to go here. But this is still not in complete order because negative 5 is still at this position in the array. So it's going to go through it all over again until negative 5 goes to index 0, and everything else is sorted in the order. So it just keeps flipping positions. It keeps checking, is this less than this or greater than this? Okay, if these two are okay, then leave them as is. If somehow we get a positive value, then we are going to flip them. And that's why it matters which order we put this in. If we say banana minus cat, then we are going to go in descending order. Do you understand that? It may take a couple days to let this concept sink in, but no, this is a recording you could go back to and try and help you understand why this sort function has to work like this to get numbers, including negative values, in ascending or descending order. Otherwise, it's going to sort things as if they were words. So that's why when we sorted this without this AB arrow function A minus B, it's going to treat it as 1 in 1,000 being in the same category, because it's just checking the first letter as if it was checking a word. It's checking
So
one.
A and B represent the entire value that's held within the indice, and the subtraction of one indice by the next indice is a comparative statement that will return, like I said, either true or false or do nothing.
Right. Okay. So I'm glad I got to introduce this to you guys. This is, like I said, a more difficult algorithm and a more difficult concept tool to help solve this algorithm in an efficient way. So maybe tomorrow we'll bring it down a notch and we'll do something a little bit easier. But it's good to challenge ourselves every now and then. Okay, so you guys will encounter a lot more difficult algos in the MERN stack, and in Python, you guys will be learning how to do algos in a new but similar language. Okay, Python, the syntax is a little bit different, but it's not going to be that much harder of algos. This is up a level from what we've been dealing with. Okay. That being said, I think we'll take any questions if we have them now. If not, we'll take a break before our next lecture.
Hey Josh, do you mind just while we have everybody here if I show them this Python tutor thing real quick?
Sure, let's do that. Yeah.
All right, so pretty much you just go to Python tutor. I don't know why my browser won't go back, and you click on the visualize code button, and it gives you this little window to copy and paste your code in there, and you can just click visualize execution. And it'll just build out a T diagram for you. So like the first thing it does is go through and sort that array. So it's showing the process of passing in those values to A and B, the value that gets returned, and then, so kind of give you an idea how that sort's working. But once it gets through the sort, which kind of takes a minute, it actually goes through and it builds all of those variables. And if you just click through next, it shows the arrow shows you what line of code it's reading, and then that's your T diagram over there showing you the value for all of your variables, and you can just click through the process and see how things are working. But it's super convenient, especially when you get into like the more complicated algorithms. So
this is awesome. Okay.
Yeah, it's pretty much like what's it called, trace, but it works like way more like smooth. I don't know, trace is kind of clunky if you ask me, but it's the same thing though.
Okay, so where's the T diagram exactly?
I guess it's really just this right here. It doesn't show like the T, it just shows all the variables you have and then their current value, and then that one number just kind of changes as you go through it. See like how it's changed. So it doesn't like make necessarily a T diagram, it just shows you all the different things. And then it also shows you down here how like the arrays get modified over time and stuff. So
So John, thank you. That's
Yeah, no problem.
nice. So do you have to click next by yourself, or it just does by itself?
I think there is a way to just get it to play. I thought there was. Maybe not. No, I guess you got to click next. But you can just scroll through it too.
So that I can control the flow because it's going by itself. So I can click every time next, then I see the value.
Yep. It just every time, like as it iterates, if you notice, every time I click previous or next, that arrow moves. So that's where the interpreter is at the moment. So it had just read this line, and now that it read that line, these are the values.
Nice, I like it.
Cool. I just want to show you guys that, especially now that you're through web fundamentals, it'll be getting more useful as you move into harder algos. So
yeah, and thank you guys for bearing with me. I'm going to find a better way to T diagram while having the code on the screen so that I'm not wasting time writing on the blackboard. So again, thank you guys. if we have no further questions, we'll break now and then meet up in about 10 minutes. Okay, let's take a break.
Gosh, you want to see my progress?